Imagine a flowing river, its water rushing downstream. But before the first stone is laid, engineers must choose the perfect location. The ideal dam site has strong, sturdy walls of rock on either side of the river. This forms a natural V, narrowing the river and making it easier to build across. A solid foundation is crucial to hold back millions of tons of water. With the perfect spot chosen, the next challenge is figuring out how to build the dam while the river is still flowing. Engineers use a clever trick to tackle this watery obstacle. They redirect the river. They dig massive tunnels through the solid rock beside the dam site. These tunnels act like detours, allowing the river to bypass the construction zone. In some cases, open channels are dug alongside the riverbed. Either way, the river is safely redirected, allowing construction to begin in a dry area. With the river safely redirected, you might think it's time to start building the actual dam. But there's one more crucial step: creating a dry work environment. Engineers build what are called cofferdams. These temporary dams act like watertight fences, blocking off a section of the riverbed where the main dam will be built. Once the cofferdams are in place, powerful pumps remove any remaining water from the enclosed area. This creates a dry, stable foundation for the dam. With the river tamed and the cofferdams in place, the real action begins: constructing the dam itself. Dams are usually built with massive amounts of concrete, a mixture of cement, water, sand and gravel that hardens into rock-like strength. Think of it like building a giant Lego tower, but instead of plastic bricks, we use enormous concrete blocks. These blocks are carefully lowered into place by giant cranes, fitting together like pieces of a puzzle to form the dam's massive wall. As the dam grows taller, layer by layer, pipes and tunnels are built within its structure. These will later house turbines and generators for hydroelectric power. With the dam towering high above the riverbed, its strong concrete structure complete, it's time to bid farewell to the trusty cofferdams. These temporary dams have served their purpose, allowing the main dam to be built safely and efficiently. Removing them is like taking down the scaffolding after a building is finished. Carefully, section by section, the cofferdams are dismantled. The rocks and earth are often reused for other construction projects, minimizing waste. The stage is set for the final act, the grand filling of the reservoir. With the cofferdams gone, the river is ready to meet its new destiny. Slowly and carefully, engineers begin closing the gates of the diversion tunnels or channels, allowing the river to flow back into its original course. Instead of rushing downstream, the water encounters the imposing wall of the dam. It begins to pool behind the dam, gradually filling the reservoir, a man-made lake created by the dam's construction. This reservoir is more than just a scenic lake. It's a precious reserve of water, a lifeline for communities downstream. Now, our dam is complete, a testament to human ingenuity, standing tall and proud, holding back a vast reservoir of water. But our story doesn't end here. A dam isn't just about holding back water, it's also about controlling its release, ensuring a steady and manageable flow. Gates located within the dam structure can be opened and closed like giant valves, allowing engineers to control the amount of water released downstream. Spillways act like emergency exits for the reservoir. They are designed to safely channel excess water over or around the dam, preventing it from overtopping. With these control mechanisms in place, the dam ensures a harmonious balance between water storage and release.